Guys, welcome as we solve this problem of electrical system modeling. I read the question. Figure shows an RLC circuit. Determine its transfer function. So guys, you can see that this is a series circuit whereby guys you have the resistor there, you have an inductor, you have a capacitor. And the current, we can take this loop guys whereby we say that the VI is the voltage across R1, voltage across RL, voltage across C, and voltage across R2. And guys, we can also take the voltage across R2 as V0, which is the output. And so guys, we begin doing the problem. So guys, here is our problem as you can see. And then guys, we are now going to take the V input, which now is given by that. That is V input. We have the voltage across the resistor is R1I. The voltage across the inductor is L di over dt plus voltage across the capacitor is that, and voltage across R2 is that. Guys, we can convert that into this, whereby we say, remember that I, which is the current, is equals to the dq over dt, whereby this is the rate of flow of charge is equal to current. Guys, we can write now these values in terms of dq dt. That is for I, this is dq dt. For this one, we now have to differentiate once again, and let's see how it happens here. So guys, we have V input is equals to R1 dq dt. For L, it's going to be squared. As you can see here guys, it was di dt, while this is dq dt. So if you differentiate I once again, you differentiate I, then this one will be differentiated once again. So we shall have the second order for that. And that is there. Plus 1 over C integral I is dq over dt. Guys, if you integrate a differential equation, differential term, this one now will become q plus R2 dq all over dt. Guys, then we come and now for the V0, which is now the output, we have R2I. This is now dq dt yet again like that. Guys, from there now we can come and write in Laplace transform. We convert that to Laplace transform. This is what guys we shall have. We shall have for the resistant, you shall have the dq dt will be SQ, that is S, plus for the inductor we shall have LS squared Q S, plus for the capacitor, remember we have the Q, so this one we just add the S there. And R2 which shall be just like this, R1. And then we come for the output. The output will be R2 SQS. So guys, we have written that in terms of Laplace transform. Guys, now we come and divide V0S all over VIS. So guys, when we divide, this is what we get. So guys, dividing, this is what now we are going to have. We have actually factored out the QS. As you can see, the QS is common in all of these terms. And so guys, we can be able to factor out the QS. Even this one has a QS. And after we have factored out guys, we come and cancel. Then we are left with this term. And so therefore guys, our transfer function V0 all over VI, that is V0S over VIS, will come to this. And so guys, this is our transfer function. Guys, we can also, like for example, we can divide every term by SC. But before we do that, guys, what we have done here is that we have put all this under the same denominator, which is C. Meaning we have to multiply each of these terms with C. And then the c that is left here, we bring it up now to come to this point. And that's where we find this c. So guys, this is our solution. But we can also divide every term of this by SC so that we are left with the R2 here. SC we divide, we are left with R1. The same case with R2, we divide by SC, we are left with R2. But guys, this is what now happens. This is now what we get if we divide both sides by SC. So if we divide by SC both sides, guys, we will get this solution. And so this is also another good solution for us. So guys, thank you for listening to me. Bye.